Welcome to the course Business Analytics and Data Mining Modeling using R. So, in the previous lecture we were discussing visualization techniques and we were discussing multiple panels. So, let us go back and restart our discussion from the same point. So, let us go back to R Studio. So, last time, at the end of the lecture we were trying to cover separate panel for each group, so that I think we were able to complete. And now today in this lecture let us move to scatter plot matrix. So, scatter plot matrix can be really useful in situations where you have many numerical variables and you are trying to understand different relationship between different pairs of variables. That is going to be useful for prediction tasks in supervised learning, prediction and classification tasks in supervised learning methods, and in case of unsupervised learning methods, it could be useful in understanding the information overlap between two variables. So, if we get to see in one go the relationship between different variables, our visual perception can be much better, especially in some situations. So, the data set that we are going to use is the same one, the users car data set. So, again, because we are starting afresh, so we need to import this particular data set again. So, let us do this. Let us reload this library. So, let us import this particular data set. You can see the data set has been imported, 79 observation of 11 variables that is visible in the environment section. Now, let us also compute this age variable, some of the things that let us also take full backup of this particular data frame that we are going to require later on in this lecture. And first the observation, as we understood in the previous lectures, were not important for some of the initial visualization techniques that we discussed. Once this is done, in the previous sessions we also identified one observation that we wanted to get rid of. So, let us do the same today as well, backup and eliminating the observation. Now we are ready to start with scatter plot matrix. So, let us go back to scatter plot matrix. Yes, so as discussed, scatter plot matrix can be useful to understand the relationships and information overlap. So, now you can see we have selected 4 key numerical variables, continuous variable for scatter plot matrix, as we understood in the previous lecture that for scatter plots both the variables that are going to be on x axis and y axis are supposed to be numerical variable. So, therefore, you can see SR price, kilometer, and price and age, these 4 numerical variables can be used to generate a scatter plot matrix. So, let us execute this code. You can see the graphic here has been created. Let us zoom in. Now, here you can see in the diagonal in the diagonal rectangles, right, in the diagonal boxes, you would see the name of the variables that have been used to create this particular scatter plot matrix: SR price, KM price, and age. You can see the function that we have used to generate this particular matrix is pairs. So, in this pairs function we have to pass on this formula. In the formula we have to mention the name of the variables which are going to be used to create this scatter plot, and then the data. So, let us go back. So, for example, if we are interested in this particular graphic, then the y axis is going to be SR price, which is in the same row, SR price, and the x-axis is going to be represented by km, which is in the same column. So, x-axis is km and the y-axis is SR price. Similarly, if we are interested in this particular graph, then we would see that age variable, which is in the same row, is going to be represented on the y-axis, and SR price is going to represent the x-axis because it is in the same column. So, that is how you can understand which variables are there in x-axis and y-axis. Now, you can look at different plots and you can try to understand the relationship between them. For example, this particular plot, you can see this is between SR price and price. You can see a linear kind of relationship is visible there. See, majority of the points, if we pass a line through the majority of points, it is going to be a linear line, right. It is going to be a linear line. So, therefore, the relationship, now you can understand from the variables itself that SR price and price both are based on prices, therefore, there is supposed to be a linear relationship. So, that is very visible in the data itself. Now, if you are interested in kilometer versus price, you can see this particular plot. So, km and price, you can see most of the points they are clubbed here in this particular group. So, there does not seem to be much difference of much difference of price on kilometer. We can also look at this particular graph. In this case, price is on y axis and km is on x axis, because price is our outcome variable of interest. This is this particular plot is of more interest to us. So, here you can see the km could be represented by this particular data could be represented by horizontal line, that actually signifying that there is not much of influence of km on in determining price. Similarly, there are different plots and different kinds of relationship can be seen over there. Now, if for example, if we are interested in some few other plots, for example, price and let us say price and age in this particular graph, you would see that because the age is being represented by few numbers only. So, therefore, you would see for a particular age cars of different prices are depicted here. Similarly, so different, so it looks like a bar chart kind of plot. So, for different age group, for different age numbers, cars of different prices are being shown there by different points, data points. So, this particular this particular scatter this kind of a scatter plot matrix can really be useful in terms of finding many relationship, understanding many relationship. It can help us in finding new variables. It can also help us in understanding the interaction terms if required. It can also help us in grouping some of the categories. It can also help us in subsetting the model. So, running a model on a subset of the full data set. So, those kind of things can actually be identified using these plots. Now, let us move to our next point. Let us go back to the slide. So, next we are going to discuss is discuss these operations: aggregation, rescaling and interactivity. So, these operations can sometimes be really useful for the same things that we have been talking about. So, let us start with rescaling. So, let us go back to our studio again. So, rescaling can be really helpful if there are crowding of points near axis, whether it is x axis or y axis. If there are many points which are crowded near those axes. So, therefore, we can do rescaling of x axis and y axis and get a better look of the data. So, how? Let us see through an example. So, in this now we are going to create 4 plots, 4 back-to-back plots. So therefore, we are trying to divide our plotting region into 2 rows and 2 columns. So 4 plots are going to be created, and we have appropriately we have changed other settings like margin, outer margin, and this size of font and size of different text and numbers. So let's run this. So first particular rescaling, that first particular example is between for a scatter plot between kilometer and price. So let's again have a look at the range. You can, as you already know, that range can be used to specify the x limit and y limit in the plot function. So you can see the appropriately the limits have been specified. Now let's run this particular plot. You would see, because as I said, we wanted to generate 4 plots in the same plot area. So therefore, you can see 1/4 of the area has been taken by the first plot. Now let's create the axis labels. You can see price versus kilometer, and you can also see the points. Now if we want to zoom into this particular plot, though we have talked about this plot many times, that there is not much influence of KM on price, but if we want to have a much closer look, right? If we want to have much closer look, then scaling can be really useful. How? We'll see. So let's change the scale of x-axis and y-axis into log scale. So when we talk about this log scaling, we are essentially changing the spacing of points on x-axis and y-axis. So points are not going to be equally spaced in x-axis and y-axis. They are going to follow the logarithmic log based scaling, and the spacing would be accordingly changed. So how that can be done? So in the plot function in R, there is this argument log, which can be used to do perform different kinds of scaling. For example, if you just want to change the scaling for x-axis, so we can say log, we can assign log as x, and then if you just want to scale y-axis, then log can be assigned the y-axis. If you want to change both the axes, then that is the case that we are doing here right now. So we have to say xy. So this is between KM and price. Now let's talk about the limits. Now limits, as in the previous plot we had used 0 to 180 for x-axis. Now in case of log, you would see that this is 10 to 1000. Reason being that 180 is more than 100, and the next spacing point, appropriate spacing point in a log scale is going to be 1000. So it's going to be like 1, 10, 100 and 1000, or in the other direction 1, 0.1, 0.01 in that sense. So therefore we have to make sure that all the values are within the range. So appropriate limit for the values to lie in the plot region, this could be the appropriate 10 to 1000 for 0 and 180. Similarly, 0 to 15 we can have 0.1 to 100. Let's execute this particular line. You can see now the visibility of all these points is much clear, and this is mainly because of the spacing change in scale, and thereby change in spacing of points in x-axis and y-axis. Now we are trying to recreate both the x-axis and y-axis, and we are also trying to relabel these axes. Now let's zoom in. So now you can compare these two plots. So here that horizontal line that can represent these particular data points is not that much visually perceivable in plot 1, but in plot 2 pretty much you can see that this seems to be a that kind of relationship. There is not much. This is a horizontal line, so therefore there is not much influence of km on price. So this is much better visible in this log scale. You can see the points, this 10, 100 and 1000. You can see the most of the points they were in this range, right, around 120, around from 25 to 120. You can see the points are still lying in the same range, but because of the change in this scale and therefore spacing of points, the visibility of these data points have changed, and therefore we can more easily perceive the relationships. So let's go back, and now we are going to create a box plot and try to understand how the rescaling can actually be helpful in case of box plot. So this is for this example we are using this data frame which we had taken backup. So why we are taking this particular data frame, we had eliminated the one particular outlier point in the data frame 1, df1. Now we want it back so that the importance of rescaling could be emphasized in much better manner. We will see that. So range of this, you can see this point is back 72. Now we have to change our limits. You can see that. So this particular box plot is between price and transmission being on the x-axis, being the categorical variable. So let's plot this. This is the plot. Let's label the axis. Now let's zoom in. Let's have a look at the plot. Now you would see the plot is in this particular case because of this particular observation. You can see one observation lying here because of this, and this observation in the automatic transmission category. Because of this observation, most of the whole box has crowded into x-axis. So therefore comparison of these two boxes is becoming very difficult. So therefore rescaling can really be helpful in this particular case. So what we are going to do is we will use the log scale. See, the log y has been selected because now only the y is the numerical variable. So therefore only there rescaling is required, and the y limit have been changed appropriately so that it covers all the data points. You can see 0.75 is very well within this particular range. And let's execute this code. You would see a plot has been created. Let's label the axis. Now you see the boxes are looking much better, and the comparison could be easily performed. Now the point which was outlier, now you can see the spacing between this particular point and the box plot, the main box plot, it has changed to a great extent, and this is the result of scaling. Now comparison could be easily done. So this could be the benefit of rescaling in some situations where crowding happens. So next discussion point is on aggregations, attaching a curve and zooming in. So we will go through some of the examples and we will see how aggregations and curve, how we can append a curve or add a curve to the existing plot, and how we can zoom in, and how it can actually help us in doing some of the visual analysis task. So so again we are going to create 4 back-to-back plot, and so the similar parameter, the pair function has been specified and called appropriately. You can see 2 and 2 rows, 2 columns, and margins have also been specified so that we are able to use the plotting region effectively. Now our first plot is in this particular case we are going to use that time series data, that riders data that we had earlier used. So let's import that particular data set. pi cycle ladder shape dot XLSX. You can see this particular data set is the time series data, the first variable being a month and year, the time scale related information, and the number of riders for every month, and this covering years from 2004 to 2017. Let us also create this time series vector that we are going to require later on. Let us also create these variables at 1, labels at 2. Now let us go back to aggregations. Yes, now once this we have created the time series vector, now let us plot. So this plotting we have done before. You can see the time series has been plotted, 1/4 of the plotting region has been covered. So because we are going to plot 4 back to back graphs. So let us recreate the axis, so x axis. You can see the recreation, the code that we are using, that is you can understand the kind of labeling that we are doing right now. You can see the day, month and year, and the same is depicted in the plot. So labels have been changed. Let us recreate the axis, y axis. This is mainly being done to accommodate, to have the axis, and also to able to accommodate 4 graphs in the plotting region. Now let us label the both the axis, month and riders. We are also going to provide a appropriate title, because we are in this particular example we are going to append or attach a curve on raw series. So raw series is displayed. Now this is the title. You can see title has been displayed there. Now lines is one function that can actually be used to create a curve. So therefore, if you are interested in finding more information on lines, you can go into the help section. You can see add connected line segments to a plot. This is a generic function. So you will have to provide the coordinates x and y. Now in this particular case, we are providing those coordinates using lowest function. The lowest function, let us find out. So lowest function is actually a smoother scatter plot smoothing function. So that actually takes the same x and y points. So these points are being taken from the time series vectors, and the lowest is applying some computations related to lowest smoother, and we are going to get a smooth line added to the plot. The color of the line has been this red. We are going to use red color for this particular line. So let's execute this code. You would see a red curve has been added. You can see that. So this particular curve has been created using the x and using the coordinates from the time series vectors. If we want a more a curve which is more representing of the data points, we should be able to approximate what this particular line graph is looking like, and then the representative curve we should be able to try and plot here. So for example, this particular line graph, this particular time series is looking to follow a polynomial curve. So probably a quadratic curve can actually be overlaid on this. So let us do that. So we will add a quadratic curve on this. So let us create this. So t, we need to create because t will become a predictor for this particular quadratic curve. So let us create t. So you would see that t has been created in the, you can see the same in the environment section. So it is nothing but a series of numbers 1, 2, 3, 4 up depending on the number of points that are there. And because this is being a quadratic, let us create the t square. So This has been computed. Now you can see that we are using a points function, which also does the similar kind of thing. It plots points on depending on the coordinates. The coordinates are being passed using the time function, and they are using time function. We are extracting these coordinates from the TSV, time series vector, and then predict. So time is coming from TSV, and we are using predict function that we have discussed before. So we are using linear modeling. So in this linear modeling, two predictors, one is t and the another one is t square. They are have been modeled into riders. So this particular prediction, they will actually give us the y coordinates and the time function that is extracting time from the TSV vector, and once both these points are there, we are plotting them using the points function. Color is green for this particular curve. So let us execute this line. You would see a green curve has been added. You can see this seems to be much this particular curve seems to be representing the line graph in a much better fashion. But you can see the connected points. See, the points have been plotted. It's not the line. The previous one was the line. So lines is the function that is used to create a line, and the points is the function that is used to plot points. But because these being series of points, we get a sense of a curve being added. Now this is also following a polynomial, a quadratic curve. So now let us also add the grid. So AB line is the function which can be used to create vertical and horizontal lines. AX ticks function can be used to get the default ticks that are generated in the plot that are generated using the plot function. So these ticks can be extracted using xtick function, and we can have horizontal lines from coming out of those ticks, and this has been generated. Add 2 that we used that we computed before has been used. So therefore you can see that these grid lines, these dot lines have been created appropriately, so that we get a so that we are able to get a better look of the graph, and if we want to compare some of the values, so we can easily understand them. Now let us come to our plot number 2. So this plot number 2 is monthly average. So we are trying to take monthly average over the years. So we have 13 years in total. So for different months, we want to compute averages of average number of riders for each month, Jan, Feb, March, similarly for all 12 months, and therefore from those, and then we want to plot them in a line graph. So we would be required to compute those averages, and so let us do this. So riders by month. So this is the variable, and 12 months are there. So let us first initialize all these 12 values, 12 variables. This is our counter. So we have total, because we have 13 months, and in the 2017 we had only 3 months, Jan, Feb and March. So therefore we have this 144 plus 3, 147 months in total. So this being our counter, I variable being our counter. You can see in this while loop we are trying to accumulate all the riders month wise. So ride by M1 is representing the month of Jan, then 2 is representing the month of Feb. Similarly the last one 12, ride by M12 in the brackets is representing the month of December, and we are trying to accumulate all these numbers, and then later on we are going to average them, so that we get the average number of riders by month, and later on we are going to plot them. So let us run this. Now there are 3 more months in the year 2017 that we saw in the data before. If you want to have a relook of the data, you can do that. DF is the data frame. can see 2004, starting from 2004 we have month for number of riders for every month, and in the last month, let's reach to the last year, you can see we have the data on only 3 months. So the code that we discussed here, these particular 3 lines are adding those 3 numbers as well for these months, Jan, Feb and March. So let's execute these lines. Now once we have all these numbers, let's take average. So as you can see, all these numbers are being divided by the number of months. So Jan is counted 14 times, and then others are there. These 3 months are counted 14 times, and then rest of them have been counted for 13 times, because there are 13 years of data. So let's take average. Now let's create another time series vector. This is now going to be using this particular data, average number of riders by month. So let's create this particular time series vector. Now let's plot it. You can see this data. Now let's recreate the axis. So we need to create labels. So x axis, y axis, and the labeling for both the axes, and then title followed by a grid. Now let's look at the graph. This is our graph. So this is aggregation by month, and monthly for every month, average number of riders over the years are being represented. So you can see that if we look at this particular graph, we can easily understand that in the month of July and August, the number of riders are at highest. So in an average sense. So in an average sense, in the month of July and August, the number of riders are on the higher side. And if we look at the other months, right? In the month of, let's say, June, there is a dip in the ridership, and then there is the lowest numbers are in the month of Jan and Feb. So number of riders are on the lower side in the Jan and Feb, because this particular data is reflecting the number of bicycle ridership in the IIT Roorkee campus. You can see initially when in the month of July and August, this particular semester, the environment is much conducive for bicycle ridership, but in the month of Jan and Feb, this cold weather, so therefore environment is not that much conducive. Therefore the ridership is also affected. So the same thing is very well captured in this particular aggregation. So let's move to our next plot. This next plot is about zooming in. So we are going to zoom into particular year. So first 2 years of data. So we are going to have a look at the first 2 years of data. So this can also be in a way, we can subset the data and then plot it. So that can also be done, or otherwise we can zoom in using this particular function. So window is the function in R that can be used to subset a time series. So we can create a new time series, a subset time series from the existing one. So TSV is the existing time series, and we can create a subset using the start and end arguments. So 2004 to 2005 data we are going to create a subset of. So let's execute this code. Let's plot. You can see the plot has been created. Let's recreate the tick marks and axis. Let's create the labels, the title, zooming into first 2 years, and also grid. Let's go back to the zoomed graph. You can see this particular line graph is representing first 2 years, and you can have a look at the data. Now let's move into the next plot. This fourth plot is actually aggregation by year. So if we are interested in looking into the global sense, we are trying to have a look at the data in a global sense. What is the global pattern? So for example, when we aggregated data using months, so that was mainly, that can be called to understand the seasonality, or if there is any seasonality present in the data. More what these terms actually mean, more discussion would be when we come to time series forecasting, but right now we can understand that when we aggregate year wise, we can have a look at the global things. When we aggregate by month, we can have a look at the full graph. The raw series gives a global trend look. Aggregation by month gives us a seasonality look. Year on year also give us a some other patterns, some global patterns. So let's do that. So we are going to aggregate this particular. So aggregate is the function. We are aggregating using mean, using this particular time series. Let's plot. So for every year, these are the riders, and this is the graph. Let's recreate the axis, title and grade. Now let's have a look. Now you can see, starting from 2004 to 2016, the data is we can see the line graph, and average number of riders are depicted for each year, and we can see overall year on year there was a dip around 2009, and after that the number of riders have been increasing year on year. So we get the overall sense over the years what has been happening. So global pattern can be seen very easily in this aggregation. So we'll stop here, and in the next lecture we'll restart our discussion with on scatter plot with labeled points. Thank you.